Okay, guys, I just wanted to record a little bit of what we talked about in class today, so you could listen to this, because it's going to be a lot more clear than if I would just try to quickly summarize everything when you come back for study hall. So I'm going to have you listen to this so that it builds the background and lets you know what you missed in class today. So we've been talking about matter, as you know, solids, liquids, and gases, and plasma. So we're going to continue that topic, slightly going in a different direction, because we're going to talk today about what is an atom, what's inside of an atom, what are the parts, subatomic particles that are in that atom, what charge do each of those subatomic particles have, their location, and their relative size. So we'll kind of build this by showing you some parts of the notes here. So we've been talking about the particles of matter, and you know how quickly they move, the amount of kinetic energy they have, what happens when you change their thermal energy. All that's still the same. It's just that now we can call those particles atoms. And then later, in a day or two next week, we're going to talk about the elements that these atoms make up. And then we'll build on that to make molecules. And then later, after spring break, then we'll talk about cells. And those, last year, these words were in 5th grade. We talked about planets, galaxies, and the universe. So atoms, a good definition of what an atom is, kind of a generic, everybody thinks of atoms as the smallest component of matter. Smallest part of matter. If you are made of matter, anything made of matter, you are made of atoms. Very, very, very small things, but humans have been studying atoms for many, many, many years, and we're still not sure. We have an idea, and I'll show you a model in class of what we think atoms look like at this point, but we're not 100% sure that we still know. And they are constantly studying that and trying to refine what that might specifically look like. We have, at this point, proved that in the middle of every atom is a location called the nucleus. So one vocab word you'll have to put in your notebook and in your brain. The middle of that atom is called the nucleus. And then the other word that we're going to constantly be using is the word subatomic particles. So these are just the parts of every atom. And there are 3 that you're going to learn about and study in 6th grade. When you get older, there are other parts. But to build this foundation for 6th grade, we need to know the subatomic particles, that what they are, and their charge, their location, and their relative size. So I'll get to that in just a bit here. So subatomic particles, the parts of the atom. An atom are the things that make up matter. Well, we're also going to introduce you to something called the strong force. That's the name of it. It's a natural force, and it is the force that is holding every atom together, these subatomic particles. It holds them within the nucleus, or the area that's surrounding the nucleus in every atom. Strong force is a force similar to gravity and magnetism in that it's natural. We can't turn it on, we can't turn it off, we can't increase it or decrease it. It just naturally occurs, and it's very, very strong. I'm assuming that's why they call it the strong force. So those are the first 4 words we discussed before we went on to talk about these specifically 3 subatomic particles. So those 3, and I'll give you this paper here for your notes. So I'll focus on each of these 3 subatomic particles. So proton first. Protons are positive, that's why I put the plus there. They carry a positive charge. They're located in that nucleus, the middle, and they are the same size as the neutron. That's the proton. Positive, P, located in the nucleus, same size as the neutron. Which brings us to the second particle, which is the neutron. And we will draw that as a circle. That's supposed to be a circle with a line, a slash through it, because neutrons are neutral. Neutrons are neutral, or you could remember that they have no charge. If your car is in neutral, you're not going forward, you're not going backwards, there's no movement, just like the neutron is in neutral charge. It is also located in the nucleus, and it is the same size as the proton. So those two are very similar. They're in the same location, they are the same size, they just have different charges. Proton, neutron, they would be in the nucleus, that middle part. Now we have the third subatomic particle. We will show that as a negative because the electron carries a negative charge, just like your negative numbers. Their location, we can describe it in three different ways. In the cloud, surrounding the nucleus, or outside the nucleus, or in something called a shell. And I'll explain all of that when you are back in school during class. They are also the smallest. Cannot tell me small because all of these items are very, very small. The size of the electron are smallest of these three subatomic particles. Sub just meaning in each atom, not necessarily under, as sub usually means. So one way you can remember electrons, you can think of it this way. After elections, people are negative. They're upset because they either lost or the person that they wanted lost or it didn't go their way. So that's one way of remembering that electrons are negatively charged. They're outside the neutron, so if they had feelings, I guess you could think that they would be mad about the fact that they're not allowed in the nucleus, and they're very small. They are the smallest of all three of these. So I guess they have quite a few things to be negative about. So those are your three subatomic particles that are in every atom. Proton, neutron, electron. Okay? And then I just drew an image down here just to show you, and a reminder, they're all held together by the strong force. The reason why they would need to have a force to hold them together is because you know that when there's two positively charged things real close together, they would repel. And so if that would happen, all the atoms would blast apart. So that's obviously not a good thing that we can handle. So the strong forces in that nucleus holding the protons together, and the same thing with the neutrons. Got to hold that in the nucleus. And then I just tried to sketch out the shells there. And those marks are supposed to be negative signs. So there is a really rough drawing of possibly what a 2D atom could look like. Okay, so you'll be getting that page when you're back in class. And then, just to show you what this could look like, this is the slide we used to review. These are the three things that you're going to need to memorize to know to build that foundation. So the names, three charges, the location, and the relative size. So this is the proton. Its charge is positive. It's in the nucleus. And its size, relative size, is same as the neutron. This, of course, then is the neutron. It's got a neutral, right? Neutron is neutral or no charge. It's also in the nucleus, and it is the same as the proton. So there you see, same size, same location, different charges. Proton positive, neutron neutral. And then the one that's really mad, you could remember, electron. It's negative, and then the locations you could describe in the cloud, around the nucleus, outside the nucleus, in the shell, all of that. I didn't have room to put it there. And then its size, relative size, is the smallest of all three of these. So there is one way you can use to study. So hopefully this helped you. See you later.